COVID going on, I think even though this is not particularly a COVID symposium, you'll see that there's a lot of usefulness in this set of talks as well for some of the ongoing crises that we're facing. So, it's a very busy 2 hours. So let me kind of get started by introducing Charles-Albert Lahal, who represents CFM, just to say a few words about the data initiative. Charles-Albert.
Okay, so hello, Harrison. Thank you. I think that I will be quite short. So, of course, CFM is very happy to be part of such a workshop once more. It's always a pleasure to address this new kind of data. And last time it was about weather data. Today it's about geolocation. And of course, for us, the puzzle is how you can infer about, any information about economics using this kind of new data. It's ironic somehow to think that because this event is virtual, geolocation will not contain any information about us talking about that today. Nevertheless, especially with all the COVID issue, we know that geolocation contains a lot of information about economics. And so we are very happy to be part of this event today. And I am sure that we will learn a lot listening to the speakers and the panel about how to use geolocation to get insight about the state of economics.
Great. All right. Thanks a lot, Charles. So let's get started. We've got three. So the structure of the 2 hours is we've got 3 academic talks at 20 minutes each. And then basically we'll take a few questions from the attendees, and then we'll transition to the industry panel. Okay. So let's get started first with Donald Davis, the Ragnar Nurska, Columbia University professor of economics, who's going to talk about the use of data from online restaurant reviews to address a number of important issues in urban economics. Don, it's all yours. Don, you need to unmute.
Okay. I should be unmuted. Can you hear me?
Yep.
Okay, let me go ahead and share my screen. And yeah, so I'm going to be talking about some work. The title of the paper, oops, let me just, is How Segregated is Urban Consumption? This is some joint work with colleagues at Chicago, Pompeo Fabra, and Princeton. So we're going to be talking about segregation. And the segregation that we're used to talking about is residential segregation. There's an easy reason why that's what vast literature exists on, which is that the data is very readily available. So this is a picture of New York City. A green dot represents 200 people who are whites. Blue dots would represent 200 people who are blacks. Orange would be Hispanic and red would be Asian. And you can see that there's still remaining. The question that we wanted to ask about is consumption segregation, right? That we live in places, and that reveals something important about the status of interracial and interethnic relations. But we also work in places, and we also sort of go about, at least we used to go about the city. So there's a long history of why you might be interested in these things. Jim Crow, of course, had separate but equal. That, of course, was never equal. The early civil rights movement was about sit-ins, the lunch counters. And Elijah Anderson at Yale has talked about the cosmopolitan canopy, the fact that sort of shared spaces allow us interaction and maybe also an opportunity to have better relations as a result of this. Now, we haven't had essentially any large-scale research on consumption segregation because the data didn't exist to do this. And so the start for us was to think about what kind of data set that you could get your hands on that would start to tell this kind of story. So we're going to be working with Yelp data, and I'll talk about it in more detail shortly. But we're going to then gather data on individuals' restaurant visits within New York City. We're going to infer what we call spatial and social frictions from the observed behavior by estimating a discrete choice model of individuals' visit decisions. Now, I'll just sort of interject here, which is that the starting point is you're really trying to think about a model of how people use the city that take account of the fact that, that there's gravity effects, as they say, which is that you do things that are near more than you do things that are far. But in addition to looking at just these spatial effects, that it takes more time to get someplace than some place near, we also want to think about the social effects, whether people are more likely to go to locations that are more similar to the kind in terms of social characteristics, say racial or ethnic composition, or income levels, more similar to the places where they live than other places. And I'll just say that we're going to estimate a discrete choice model. We're going to use the model predicted consumer behavior to project what the behavior of all people in New York City is. And then we're going to use that to measure consumption segregation in the city as a whole. And I'll give you an application with applications to 3 neighborhoods in Manhattan. So this is sort of the starting point for the data. Yelp has these venue pages, and they also have user pages. For the venue page, you can see the type of restaurant that it is. You can see a quality measure, the number of stars you see up here. You can see a price measure that's fairly coarse, but $2 signs. And you can see a location. Now, very importantly for our things that's absolutely crucial is people will frequently tell you in their review that it's close either to where they work or to where they live. And so we can locate with a certain amount of precision where people live, where they work, and from the places that they review, we can also see where they go. And we can combine this with other data on sort of regular census data at the tract level. We can combine it with information about crime in various locations in the city that we got from the NYPD. We can also, interestingly and importantly for us, we can also get individual level measures. So we're inferring that Javier is apparently a male, that he's white or Hispanic. I could go into more detail about how that imputation is made, but we're going to know where they live, where they work, and a measure of where they go. And so you can see what the home and work locations look like of the people that enter. And so I should mention, we then identify these locations. And we were using Yelp data from 2005 to 2011. So we ended up with a sample of 440 individuals visiting 18,000 locations in the city, or 18,000 visits. So there's obviously overlap about where they go. Home locations are more dispersed than work locations for the reason that Manhattan is a work center. So that's as you would expect. This is taking 2 individuals and just showing you where their home location is, where their work location is, and where they visited. And you can see the role of distance. You can also see some role for particular locations, may have unusually high quality restaurants that draw people in, but that's going to be sort of what the data looks like for an individual. This is a set of venues that are visited in our sample. We're also going to then throw in, as I mentioned, some census data, and also what we call the Euclidean demographic distance between your home location, what are the racial and ethnic characteristics of that location, versus the location that you're going to be visiting. to get some notion of how much social friction there is in visiting a particular venue. Time is limited, so I'm going to show you pictures rather than tables. This gives you a left shift of the restaurants that you actually visit versus those that are available to you, but you don't visit. And that's just to say that we allow you to travel by public transit from your home, from your work, and also from the commuting path between them. And you can see that gravity is at work, that people go to places that are near more than they go to places that are far. The same thing holds true from their work. This just gives you some sense that that our locations of people aren't crazy. And you also see it in the Euclidean demographic distance. People go to places more like their home location than they go to places that are different than their home location. Okay, so let me just tell you what sort of the bottom lines on these things are. So with spatial frictions, if you think of a place that's half as far away in travel time, you'll be twice as likely to visit it by public transit, all else equal, and 4 times as likely to visit by automobile. Again, this is giving you some sense of the magnitude of the spatial frictions, how people use the city. On the social frictions, a visit to a venue that's 1 standard deviation closer in our Euclidean demographic distance measure, you're going to visit with a 27% higher probability. And that's the equivalent of making that location 21% closer. We can also, I mentioned we have individual level measures of race and ethnicity, and basically all of these results will go through. We did look at interaction of Euclidean demographic distance and what you can think of as an area measure of spectral segregation index due to Eshenique and Fryer, asking, is it different going into a neighborhood of the other if it's right at the edge or right at the center? And it seems that these frictions start up the moment that you go into that different neighborhood. It doesn't matter whether you're at the edge or at the center. So with the estimates that we have in hand, and taking a little bit of liberty to apply this basically to everybody in New York, we can predict the restaurant visits of people in New York down to the venue level. And we can use these to construct consumption segregation indices, okay? Or consumption dissimilarity indices, which is the most common measure of segregation. So just look for a second at the first 2 columns. The first is the measure of residential dissimilarity that is very familiar. Level and sort of, you could read these as Asian, non-Asian residential dissimilarity, Hispanic, non-Hispanic, Black, non-Black, white, non-white. And these ones are very high. That's considered very high level of segregation. These are more moderate, the Asian, non-Asian, and Hispanic, non-Hispanic. What we have in the next measure of consumption dissimilarity. And what you can see is that these are a little less than half typically as large. So consumption segregation is something less than half as high as residential segregation. Now that's not something that's a necessary consequence of the exercise that we're doing. The fact that you can move around means that you could observe higher levels of segregation and consumption because people could seek out venues that are more segregated than even than the places that they live, if they lived in the places where they live for some other reason, like convenience to get to work. So because we have a model though, we can also do some exercises where we set the coefficient on spatial frictions to 0. This is essentially asking if, because one of the worries is that we know that residences are segregated. We know that people like to go things that are near rather than things that are far. How much is the segregation that we observe due to the fact that you're inheriting the segregation that exists in residences? And the answer here, you'll see that the numbers in this no spatial, we're essentially setting those spatial frictions to 0. And again, now predicting again where people will go and getting the dissimilarity indices again, you do see that there is some drop off as we go from the estimated consumption dissimilarity to that in which we've shut off all of the spatial frictions. But it's not dramatic, you know, 0.71 to 0.67, 0.142 to 0.88, okay? Excuse me, oops, I'm looking at the wrong one. I should be looking here. The other things that we do is to set the social frictions to 0. So we leave the spatial frictions in there, and we in effect ask, if you didn't have these differences that you don't want to go into the neighborhood that's different than the kind of place where you live, if we set those to 0, by how much would the consumption dissimilarity indices fall? And you can see that they fall further than setting the spatial frictions to 0, that there's a much bigger drop off. And we could look at this also pairwise by group, how much they segregate from each other. So I think that I've said that so we're going to do a little exercise here. We're going to look at this in terms, try and visualize this in terms of consumption segregation for 3 community boards in Manhattan. And they're going to be the Upper East Side, which is primarily white, Central Harlem, which is primarily Black, with a large measure of Hispanic, and East Harlem, which is primarily Hispanic, again, with a significant number of Blacks. And we'll look at consumption share under our counterfactual in some figures. And the way that you're going to look at this, I'm going to show you some pictures. Each dot that you're going to see is going to have a color. Again, green is white, blue is Black, orange is Hispanic, and red is Asian. And each dot represents 10% of the census tract population. So let me just go and look at this. Here is the residential segregation. You can see very clearly, this is primarily a white area with the scattering of Asians and not a lot else. This is Central Harlem. This is Central Park, just to orient you. This is Central Harlem, primarily Black with some Hispanic and a scattering of others. And you can see this is very clearly East Harlem, primarily Hispanic. In terms of our estimated consumption segregation, you can look at it here, and you can see that it's less, right? Everything is more integrated than it was before, but you can still see, you know, Harlem is primarily Black with the scattering of Hispanic and some others. This is still primarily Hispanic. The Upper East Side is still primarily white. I mentioned setting spatial frictions to 0. Supposing we left the social frictions in place, but we just said instantly anywhere in a city, what would that do? And the answer is it would largely leave things intact. Harlem still looks primarily Black. Yeah, there's more integration of East Harlem and definitely some more of the Upper East Side, but there's no problem distinguishing what is the primary group in each of these areas. Now we'll put the spatial frictions back in, but we'll get rid of the social frictions. And you can see that it's changing quite a lot. That in moving from here, where sort of, again, this was primarily Black in Central Harlem, it's much less clearly primarily Black once you set the social frictions to 0. Similarly, in terms of East Harlem, and somewhat in terms of the Upper East Side. And you can see also that if you set both frictions to 0, that these two actually look pretty similar. That the, again, what I would say overall is that, again, our measure of consumption segregation in the city using the Yelp data on visits and our estimates about the spatial frictions and social frictions says that in the aggregate, consumption segregation is about half as large as residential segregation. You can think about trying to do things that sort of integrate the city to a greater extent if you had transportation projects, Second Avenue subway. You can think about lots of things that would integrate the city. It doesn't actually integrate consumption that much more. What's really key is to knock down the social frictions. I think that, for us, one of the things that was exciting was this data was not designed to answer this question. And yet going on there in a little creativity in terms of being able to realize that it was possible to geolocate these people, both home location and work location, and to use the measure of where they're going, and to identify who they are, both by where they live, the social characteristics, including race and ethnicity, and also income levels of where they live, but also to see, do men use the city differently than women? Do Hispanics respond to Asian community different than, et cetera, et cetera? That these all become questions that previously were really unanswerable, and now we can give definite answers. So I'll stop there.
Great, thanks a lot, Don, for that very creative paper. I'm seeing some Q&A already, but let's hold off on that. If the speakers can just hang on, we'll go through all 3 talks, and then we'll have some like 5-minute Q&A, and I'll bring up some of the questions in the Q&A list. Our next speaker is Senpai from the Mailman School of Public Health. He's an associate research scientist there. He's on this very famous paper in Science on modeling the transitional dynamics of COVID-19 in China and the USA. Sen, it's all yours.
Okay. Okay. Good morning, everyone. So my name is Senpai. I'm an associate research scientist at Mailman School of Public Health. So today it's my pleasure to talk about our recent works on modeling the transmission dynamics of COVID-19 in China and the US. And particularly, I will talk about how we use geolocation data to inform the epidemic models we use. The first question, why do we need a model here? Modeling is useful in a pandemic in 2 ways. First, we can use a mathematical model to study the disease transmission mechanisms. And we can also use models to estimate key epidemiological parameters. And those parameters are typically not observed in surveillance data. For instance, the basic reproductive number R naught, so which quantifies the transmissibility of a disease, is the average number of infections one infected people can lead to in a susceptible population. And so second, we can use mathematical models to forecast or project the future course of an outbreak. And we can use those projections to evaluate strategies to control a pandemic. And those are very useful tools for decision making. And here I will use 2 studies on COVID-19 to showcase the utility of mathematical models in a pandemic. And in the first one, we focus on the undocumented cases of COVID-19 in China. And in the second one, we will do projections of COVID-19 spread in the United States. So first, let's move on to the first study. So there are several reasons we focus on undocumented infections of COVID-19. The first, for endemic seasonal coronavirus, there are a lot of people, a lot of infections with no symptoms or mild symptoms. So our group has performed a random sampling in Manhattan, and we swabbed people and we tested the virus it carries, and we found that for seasonal coronavirus, only 4% of carriers will go to see hospitals, and most of them still go about their lives. And also, at the beginning of the pandemic, it's a chaos, and there's a lack of testing. So there might be a lot of people who are infected were not tested and confirmed. And lastly, the reported cases in China in these early days is not enough to explain the fast spatial spread of this disease in the country. So we decided to build a model to simulate the transmission of the coronavirus between 375 cities in China. And we focus on the study period between January 10th to January 23rd. And this is before travel restrictions are effected in China. So we use a metapopulation model in this study. Here is an example of the structure of this model. And here the circles here represent locations or cities. The links between different circles represent the human movement or migration processes that connect different cities. Now, within each city, we describe the transmission dynamics of the disease using classical SAR model or SEAR model. And those dynamics is coupled between different cities through the migration process. And we can use geolocation data to inform the migration process. And so we can use geolocation data as an input into this model. So here is the detailed structure of the metapopulation model, SEAR, metapopulation SEAR model we used. We divide the total population in each city into 5 compartments. The subset of people exposed, documented infection, undocumented infection, and removed people. The transition between these compartments is described by this set of differential equations here. The terms in the left box shows the transmission dynamics within each city. So it's a classical SEAR model. And on the right, these terms explain the cross-city transmission. It's a coupled term in the equations. And we also introduce several parameters into these equations, and those include the transmission rate of documented cases, also the relative transmission rate of undocumented cases, the latency period, the infectious period, and the reporting rate. And also we introduce a mobility factor theta here. So particularly we are interested in the fraction of undocumented infection and also their relative contagiousness. So we noticed that in the equation, there's a mobility matrix M, which represents the migration process of people with human movement between different cities. And we will use data to inform this mobility matrix. Now we have a model, we need to combine this process-based model with some real-world data. So for this human movement between different cities, we use geolocation data. So for COVID-19, it's really unfortunate because it overlaps with the largest human migration on Earth. We call it Chunyun. It's travel during Spring Festival in China. In 2018, there were 3 billion trips recorded in 40 days. So that's a massive human movement there. We use Tencent location-based surveys to track those movement between different cities. And those services include WeChat, QQ, Maps, etc. And they have very deep penetration into the population because a lot of people use WeChat and they use that to make online payment. And we use those daily intercity movement during Chunyun to build this this transmission, this migration matrix M. Because the data cannot capture every trips during these days, so we also introduce a multiplicative parameter to adjust this intercity mobility. So apart from this geolocation data, we also use surveillance data of disease. We use daily new confirmed cases in each city to optimize the model. Now we have a model, we have a data, we use the Bayesian statistical method to optimize the model using those data, and we estimate parameters in these models. So here in this figure, we show the model fitting to the observations of, here's national daily cases, Wuhan daily cases, that's epicenter of the of COVID-19, and also Hubei province daily cases here. So we estimated that about 86% of infections were undocumented before travel restrictions. And per person, the transmission rate of undocumented infections was about half of documented infection, so they are still contagious. And we estimated the effective reproductive number is about 2.4, which is much higher than seasonal influenza and also H1N1 in 2009. In 2009, H1N1 is about 1.5. And also we estimated the undocumented infections are the source of about 79% of documented infections. So even though they are less contagious, but because of their large number, they are the major source of infections of the confirmed cases in China. So that's the major finding of this study. And this findings shows asymptomatic or mild symptomatic infections are widespread for COVID-19. And they still have considerable ability to transmit the virus. And those findings are from model estimate. And later and more recently, those results has been validated by recent lab studies. And those features, those epidemiological features of COVID-19 imply that it has a very large potential to become a pandemic. And now we know it happened. And it will be really challenging to control due to the existence of silent spreaders and stealth transmission chains. It's because these people, they were infected, they didn't know they were infected, and they still go to the shops, go to the street, and they can still transmit to other people. And to effectively contain this pandemic, strict social distancing is required before we have any vaccine. And those is even for people with no symptoms, because they might have the symptoms, but they don't know. And next, let's move to the modeling in the United States. So we have built a similar metapopulation SEAR model for US as county levels. And for this model, we use work commuting data from census survey. It records how many people lives in one county and works in the other county. And here in this map, we visualize this data, and we can see there's some dense connections in some metropolitan areas. We use this model, we use this data to build the metapopulation model we used to do projections for COVID-19 in the United States. So we use a similar statistical method to infer the model parameters based on the county level data from February 21st to March 13th. And we estimated that the reporting rate in the early weeks in the United States is very low. It's only about 8%. So and this is probably because there's a very low capacity of testing at the beginning. The New York Times has compared the daily testing in 3 countries in the United States, in Italy, and in South Korea. And we can see, even though the United States has a much larger population, the daily testing in US is much lower than those 2 countries. And this is very likely the reason why we have very low reporting rate in the United States. And then we use this model, we tested the effect of several potential control measures. And we consider 3 scenarios, hypothetical scenarios. The first one is we assume we do nothing, there's no intervention. So it's here, the first row shows that scenario. And also we compare 2 social distancing scenarios. In these 2 scenarios, we assume the contact rate in the equations is reduced by 25% or 50%. And the second row shows the situation for 25% reduction. And the last row shows the situation for 50% reduction. And the map shows the daily confirmed cases on 3 points, April 1st, May 1st, and June 1st. So what we found is if we do nothing, if there's no effective interventions, COVID-19 will spread to the entire US within a very short time. And this result was published in New York Times on March 20th. And we just trying to raise awareness of the seriousness of COVID-19 in the United States. And later we have upgraded the model and generated more projections in 3,000 US counties. And those projections include daily cases and death, hospital bed and ICU demand, and also ICU capacity in each county. And we also developed several visualization tools to show those projections. And those projections were updated every week. So it may be helpful for those decision makers. And so when we do this projection, we found it's really hard to do projections for COVID-19. And this is because human behavior will change during a pandemic. So people can change their behavior because the awareness of infection risk, and also there's a shifting control policy in different states. So geolocation data here can help us to capture some of the mobility change of people's behavior. Now we have access to two different geolocation data. The first one is from Cubic. It's a mobile phone data. It measures the distance of movement of individuals in the data set. The second one is SafeGraph data. It measures the number of visitors to point of interest, POI, for instance, restaurants, stores, or supermarkets. And we can use those changes to see how people's behavior changed over time. And this map is produced by the New York Times, and it shows the change of people's traveling distance in the United States at county level. The gray color means there's less traveling, and red color means there's a like normal travel level. And and we can see there's a significant decrease in the northeastern US and also somewhere in the West Coast. But there's still some normal level traveling in the southern counties and also in the middle of the US. And I mean, both those data, both cubic data and SafeGraph data, they are indirect measures of close contact. So we cannot directly translate the reduction of these numbers to modeling, to the parameters in the model. So for instance, if on average people's traveling distance reduced by 95%, it does not necessarily mean the contact rate in the model will be reduced by 95%, right? So it's a problem how to translate those data to model parameters. For cross-county movement, it's relatively easier because we have the SafeGraph data to measure the number of visitors from other counties in POIs. And we found that by the end of March, those number has been reduced by half. So that's a significant reduction of cross-county movement. But for within-county movement, this is not very straightforward, and we are still working on that. We try to find the mapping between the reduction in people's traveling or other measures, mobility index, to the change of parameters in the equations of the model. And then other thing we should know is United States is a very large country, and there's a huge difference and a large heterogeneity between different states. And currently, so cases in some states are still increasing rapidly, like Massachusetts, Illinois, Maryland, Indiana, Virginia. So it's still increasing, and also in some states, the numbers is getting stabilized, like New York City, New Jersey, Pennsylvania. There's a plateau happening here, and also in some states, the numbers are already declined. The peak has already passed. So here in this figure produced by a Maryland Transportation Institute shows the change of people's movement in different states and at different day. So this is from cubic data. The color here shows the social distancing index, which is the average length of movement of people within that state. So each row shows one state, and each column shows one date. Now we can see there's a clear pattern here. So before March 15th, March 13th is pre-pandemic phase. There's almost no social distancing. It's pretty regular. You know, this band here is weekends, I think. But starting from March 15th, there's a behavior change phase. So the movement here reduces significantly from the normal level to about, you know, a very low level. And the axis, the X symbols here indicate the statewide stay-at-home order date. And after this phase, this behavior change phase, there's a holding steady phase, which means, you know, people is holding their stay-at-home, holding their control measures. And more recently, there are several states experiencing quarantine fatigue, and we can see the color is becoming red again. So in those counties, people are, you know, control measures are losing up. So based on this fluid situation, it's really hard to make projections into the future and to see whether we have reached a plateau or whether it will be increasing or decreasing in the near future. It all depending on the measures taken at different states. And there's a lot of questions here about reopening the economy. The first one is there's a lot of debates about digital contact tracing, which has been used in China and South Korea. So in South Korea, they use mobile phone data, they use credit card data, so they can track the movement of confirmed cases. But you know, this also raised some privacy issues here. So, but I think contact tracing is very important because of the large number of asymptomatic infections. And about reopening the economy, it is really important to know the mapping between movement reduction to the reduction in transmissibility. We need to know at current level, what's the wiggle room we have for relaxing control, so we can allow some people get back to work, but at the same time, we don't allow the R0 going about 1, so the epidemic will be resurged. So it's really difficult to do right now, and especially in such a fluid situation. And I think, you know, if we want to safely reopen economy, first we have to do more testing. We have to make testing more available, and also we should have the capability for effective contact tracing for infections for those infected person. And lastly, I'd like to thank my collaborators from Columbia and other universities, and also from Microsoft, who helped us to develop the visualization tools. And they have contributed a lot to these modeling works. And also, and lastly, thank you for your attention to this talk.
Great. Thanks a lot, Sam, for hitting the 20-minute mark. I just wanted to alert the speakers to that in our webinar, we have a Q&A function. I think the questions are lining up for Don and also for Sam. Feel free, I think, given that we're going to have too many questions to kind of focus on a couple, you can kind of answer in the Q&A. If you look down on your screen, there's a Q&A function. You can start answering on some of the questions. And then kind of in the last 5 minutes, I'll try to, you know, maybe synthesize or bring some of these and get a discussion going. Thanks. Okay. All right, our next speaker is Franklin Chen. He's a doctoral candidate at Stanford University Economics. He's going to present the usefulness of geolocation data in evaluating the effects of rent control expansion in San Francisco. Franklin, is all yours.
Thank you very much. Can you guys see my screen?
Yeah.
Oh, sorry, not 1 second. Okay.
Great. We can see it.
My screen? Yeah. Okay. Well, good morning, everyone. My name is Franklin. I'm a 5th-year economics PhD candidate at Stanford University. And thank you very much for inviting me here today to talk about the cost and benefits of rent control. And this is joint work with Rebecca Diamond and Tim McQuaid, both at the Stanford GSB. So as we know, in the US, many cities have been experiencing rising rents, and that has reignited the debate on whether we should expand rent control. The states of Illinois, Oregon, and California have all recently considered repealing laws that prevent local municipalities from enacting rent control. And here in the Bay Areas, we already have rent control, with 5 cities recently voted on rent control, and it got passed in 2, including the city of Mountain View. And when we looked at previous research on rent control, it has warned us against the negative efficiency consequences of rent control. There is evidence on housing overconsumption when you make it cheap, and evidence on misallocation. So that could be mismatch between housing types and household types and housing types. There is evidence on negative neighborhood spillovers. So if you have a lot of rent controlled properties in one neighborhood, that potentially impacts the other properties in the neighborhood as well. And finally, there is evidence on maintenance underinvestment. So landlords potentially don't take care of their properties if they can't price it into the rents. But when you talk to affordable housing advocates, they would argue that tenants greatly value rent control. And that's because it's very hard to insure yourself against the risk of rising rents. And there is really no market to buy this type of insurance. But rent control could be one way to provide such insurance. So in this paper, we're going to study the benefits of rent control to tenants, as well as its costs and inefficiencies. So let me first tell you something about the background of rent control in San Francisco. It got first started in 1979 to cover all large multifamily structures with 5 units or more that are built before 1979. And landlords of those structures cannot raise rents within a tenancy by a preset amount by the government, but between tenancies, they can reset to market rate. But one big exemption at the time was small multifamily apartments with 4 units or less, and they constitute about 44% of the total rental housing stock. However, in 1994, there was a ballot initiative to remove this exemption that says if you're living in a small multifamily structure with 4 units or less that are built before 1979, all of a sudden you are under rent control. But if you are living in a same type of apartment that are built in the 80s, then you do not get rent control. And this is the variation we're going to leverage to tell something about the how landlords and tenants value or dislike rent control. So to do so, we're going to bring new data to this setting. We have the universe of address level migration history data for anyone who has ever lived in San Francisco. And we're going to link that data to assessors' property records, where we know the name of the property owners. So by matching last names, we can tell who's an owner versus a renter. And we also have the age of the building as well as number of units in the structure. So we can figure out who's subject to this rent control law change. Combining this data and the natural experiment, we're going to compare households who moved into their apartments in the same zip code in the same year. So, but one moved into an apartment that later on became rent controlled, and the other moved into a similar property just down the street, but did not receive rent control. And we can also look at how landlords respond to the rent control treatment. So instead of following individuals, we can follow how the buildings or the parcels, and look at changes to the parcel as far as conversion to condos, changes to owner occupancy or redevelopment, and look at how landlords respond to the rent control treatment. We have a companion paper in which we use this natural experiment to identify a dynamic discrete choice model. And we use a new difference in difference style estimator that builds on the conditional choice probability method in the dynamic discrete choice literature to identify this model. And where we focus on a particular set of options that tenants can make to help us simplify the dynamics in the long run, and to just focus on the dynamics in the few periods. But today, due to time constraints, I'm going to be focusing my discussion on the reduced form results. To give you a preview of the reduced form results, we find that the tenants who receive rent control are 12% more likely to remain at their 1994 address at the time of the law change relative to the control group. And they're also 7% more likely to remain in San Francisco as a whole. So it's not just keeping you longer at the place where you stay, but also potentially dramatically changing the neighborhood you are staying in. We also find that landlords trying the hardest to push out tenants covered by rent control in places where they have the most to gain by resetting to market rate or converting to condo. In particular, we find in neighborhoods where the market rate rent exposed has gone up by a lot, landlords disproportionately kick out more tenants covered by rent control. We also looked at the amenities consumed by those treated versus not. And we find that tenants covered by rent control consume worse neighborhood amenities in terms of observables. And that is, again, because places that has the best amenities are the places where landlords have the most incentive to push out tenants covered by rent control. When we looked at the property effects, we find a 25% reduction in the number of rent-controlled rental units, an 8% increase in owner occupancy, and a 7% increase in redevelopment. So you get this huge evasion of rent control at the property level. And the effect is actually strongest in places where landlords have the most to gain by doing so. And the last thing we looked at is investments and renovations. And again, we find a significant amount of investments to upgrade your housing stock to better cater towards higher income households. So taking all the evidences together, we actually find rent control was fueling gentrification in San Francisco, making the housing stock overall more desirable for higher income households. And in our welfare analysis, we find that the younger households on average benefited more than the older households who received the rent control treatment. And that's because the younger households, they are on average, they just need to move around more. So it is harder for them to keep staying at the same place to keep monetizing the value of rent control. And we find that most of that benefits comes from below market rent, as well as what we call tenant buyouts. So that is when the landlord can pay you a certain amount to move out, and it will be rational for you to do so. We find significant but small effects from other channels, such as you having fewer moves, thus lower moving cost, as well as you having more neighborhood capital. So that is this idea that the longer you stay at a neighborhood, the more attached you are. When we aggregate all benefits across different channels, we find that the tenants covered by the 1994 rent control benefited the equivalent of about $2.9 billion. But there is this separate GE welfare effect, where now we have expanded rent control to one sector of the market, but what happened to the market rate rent overall in San Francisco? From our model, from our reduced form results, we see a 6% reduction in total rental housing supply. And from our model, we can infer how much the market rate rent must have gone up in order to have supply for the demand. And we find a 5.1% increase in market rate rent across the city, across different housing types, which implies an aggregate welfare loss of about $2.9 billion, which almost offset all the benefits of rent control to the cohort of tenants that received it. And further, 42% of that GE welfare loss are going to be borne by future residents of San Francisco who are made worse off. The data sources for this project, so we have geolocation data from Infuder, which gives us the entire address histories of anyone who has ever had an address in San Francisco between 1990 and 2016. They provides us the exact street address, dates of residence, and some basic demographics. And we're going to link Infuder to transaction records and text records of properties from DataQuick so that we can know every characteristics of the building. And we also have some data from the government that tells us about parcel splits, which corresponds to things like conversion to condos and redevelopment. And also some data on permits issued to buildings. And finally, for rent, we're going to use a couple of different data sources to impute rent at the zip code level at annual frequency. I don't have too much time to go into the representativeness of the data, but we have done various checks of the input data. For example, we have counted the number of raw populations, as well as checking the distribution of building age, as well as ownership rates at the census tract level, and have compared those with the census or the ACS, and we find the data to be overall quite representative. And as time goes on, we actually hit about 100% of the total population in San Francisco. So let's first start by looking at some reduced form evidence by following the tenants over time. And we're basically going to use a difference in difference design here, where the treatment group are renters who are living in small multifamily apartments that are built between 1900 and 1979 at the end of 1993. Our control group are going to be renters living in the same type of apartments, but are built in the 80s. And in our control group, we're going to exclude buildings that are built for less than 3 years at the time of the treatment to get around this concern that maybe the super new buildings are quite different. And in all of our regressions, we're going to include zip code by year fixed effects. So we're going to compare two households who started in their 1994 address at the same time. And we're also going to include year of move-in by year fixed effects. So we're already going to compare two households who at the time of the treatment have stayed at their address for the same number of years. And when we use a smaller set of buildings that are built between 1960s and 1979 as our control group, as a robustness check, all of our results still go through. Here's a map to show you where the treat versus control units are. The purple dots are the treated units, the small multifamilies apartments that are built before 1979. And the green dots are the control group. They are the small multifamily apartments built in the 80s. As they are newer buildings, there are fewer of them. But they are still scattered across the city to give us good coverage across different neighborhoods in San Francisco. Here's our first difference in difference result, where I'm showing you the treatment effect on your probability that you are staying at your 1994 address at the time of the law change. And we see that prior to the law change in 1994, relative to the control group, there is very little difference in the probability that you stay at the same address for tenants who receive the rent control treatment. But that dramatically shoots up after the law change and eventually goes down. And that is not so surprising because you have to keep staying at the same place to keep monetizing the value of rent control. But eventually people do get shocks, so they started to move away. And this red time series in the background are log real medium rent that has its long run trend removed. And the fact that these two time series have a pretty high correlation is suggestive evidence that when people really want to keep staying at their address is when market rate gets really unaffordable and people expect rents to keep going up in the future. What's really interesting is the treatment effect heterogeneity. Here I'm showing you people who are older than 40 years old at the time of treatment. And these people are also, they have stayed at their 1994 address for less than 3 years. So these are high turnover types. And when we focus on the set of neighborhoods where we see the market rate rent ex post has gone up by a lot, we actually find a negative treatment effect, which means that you're less likely to stay at your 1994 address if you receive rent control. And why is that? That's because in places where it gets most expensive is when landlords have the most incentive to push out tenants and convert to market rate. And if you're a high turnover type, you'll probably be pretty happy if the landlord pay you to leave. So these people in the treatment group have this extra force to push them out that the control group don't have. But on the right, when we look at the set of neighborhoods in which the market rate ex post did not go up by a lot, people in the treatment group do tend to stay a bit longer. And that's because the landlords don't care as much there. We can also look at whether you consume better or worse neighborhood qualities, neighborhood amenities as a function of treatment. So here, we're still doing a difference in difference, but the outcome variable is median house value in the census tract that contains your address, which is a proxy for neighborhood quality. And you can do this with other types of neighborhood quality measures, and you get the same result. We actually see a huge negative treatment effect, which suggests that tenants who receive rent control go to less expensive places. And this is again consistent with the story that in places where it gets most expensive, landlords have the most incentive to push out people. So some of the tenants covered by rent control are going to be pushed out of their original neighborhoods and go to places of lower socioeconomic status. But you might wonder, this is just because the places they started with got worse over time, but that is actually not the case. Down here, I'm showing you this kind of factual where we assume the treatment group just stayed at their 1994 address at the time of treatment, but we allow the control group to move around as they do in the data. And we actually find a huge positive treatment effect, which suggests that had you stayed at your 1994 address, you would have actually be consuming better neighborhood amenities. But in reality, you're consuming worse neighborhood amenities. And that is again because of this selection effect where landlords wants to push you out. Next, let's turn to the property effects, where we follow the properties instead of individuals over time and look at how landlords respond to the rent control treatment. We find a 15% decrease in the number of renters and an 8% increase in the number of owners at properties that are treated by rent control. And this is evidence that there is huge substitution of renters by owners at buildings that are treated by rent control. And we also find a 25% reduction in the renters who are still living at properties treated by rent control, and a 7% increase in the renters living in redeveloped buildings. So this is evidence that landlords respond to the rent control treatment by actively knocking down their building and rebuild. And once you rebuild, the new buildings will not be subject to the rent control treatment anymore. And the last thing we looked at is conversions to condos. And we find an 8% increase in condo conversion and a 5% increase in renovation permits. So again, this is evidence that landlords puts in a significant amount of investment to upgrade their housing stocks to cater towards the preferences of higher income households. So taking all the evidence together, we find that the rent control was actually fueling gentrification in San Francisco by making the housing stock overall more desirable for higher income households. And let me tell you a bit about the welfare analysis we do in the companion paper. There, using our model estimates, we find that the younger households that are treated in the 1994 rent control cohort on average benefited about $2,300 per year. And that is much less than what the older households benefited, which is around $6,600 per year. And that is because the younger households, they have a greater need to move around. It's more costly for them to keep staying at the same place to keep monetizing the value of rent control. And we see that most of this benefits is actually coming from below market rent, as well as the inferred payoff between the landlord and the tenant, where the landlord can pay you a certain amount to move out. And the benefits coming from other channels, such as you having more neighborhood capital, you having fewer moves, thus lower moving costs and moving less further, or better neighborhood amenities, their benefits are smaller. When we aggregate the welfare benefits across different channels, we get that the 1994 cohort that received the rent control benefited by about $2.9 billion. And the last bit we do is we look at this GE effect of increasing market rent due to rent control in San Francisco. So from the 6% rental, from the 6% decrease in rental housing supply, we can infer that there is a 5.1% increase in overall market rate rent in San Francisco across different housing types, which corresponds to a welfare loss of about $2.9 billion. And further, 42% of that welfare loss are going to be borne by future residents of San Francisco, making them worse off compared to the incumbent residents who receive the rent control. So to conclude, we do find that tenants value rent control, although most of the benefits come from below market rent. And older households on average benefited more because they don't have a need to move around as often as the younger households. But there is this separate GE welfare loss due to rising rents in San Francisco, which lead to a lot of welfare loss. And landlords try very hard to get out of rent control by knocking down their buildings and trying to get out of rent control. And that ultimately fuels rent gentrification in San Francisco. So one potential solution to provide rental social insurance is to provide a government subsidy that is tied to the neighborhood instead of tying to the physical properties to undo a lot of the locking effects. And I think optimal rental social insurance is a point of future research. Thank you very much for your attention, and that's all I have for today.
Great, thanks a lot, Franklin. I think we started 5 minutes late, so that I think we're about we'll probably have to spill over into like 1:05. But I think in the interest of time, I'm going to switch over to the panel, and then maybe we'll fold up all the questions. I think kind of one of the things that will be kind of interesting to highlight, I think, across all three talks, is that the effects of COVID have been very uneven across groups, right? I mean, it's been kind of hitting minority groups, older groups, obviously for certain reasons. And I think kind of all three talks, I think, kind of link up together in terms of maybe kind of providing us some ways of trying to understand how to think about the uneven impact of the virus thus far across America. So maybe we'll kind of come to that at the very end of the, maybe we can pull that in as part of the panel. So I'm going to introduce then Jose Shankman, who's going to take over now the program and moderate the panel. Jose, you there? Jose? Jose?
Can you unmute, Jose? Yeah.
Yes. Can you unmute Jose? Thank you.
All right. Thank you, Harrison, for organizing this very good conference up to now. And it's my pleasure to introduce the panel discussion. We have 5 panelists. 2 of them come from Infutor. They are Brian Burke and Grace Kingston. And Infutor has already been mentioned in Franklin's talk, of course, but it's a company that specializes in data-driven consumer identity management. That's their main specialty. Then there will be Michael Recce. Michael Recce is part of it's the leader of the data source team in global asset management at Neuberg Berman. And finally, Yanis Tsounis, who comes from Advanced Research Corporation, who works with geolocation data for financial institutions. So the idea is that we have a limited amount of time, so I would ask the speakers to start by making a presentation of no more than 5 to 7 minutes, and then we'll go, then we'll start question and answer interaction among the speakers.
Jose, we have Sylvain also Champonneau. You remember him as our student years ago. He's also on the panel.
Who's that?
Sylvain Champonneau. He was our student 15 years ago at Princeton. He's also going to be.
Oh, he was, yes, Sylvain Champonneau. Yes, who is from CFM. Yes, I forgot that Sylvain would also be in the panel. Thank you. Sorry. Thank you. So let me pass the word to Brian Burke and Grace Kingston. I don't know who's going to present for Infutor.
We both will, but I'll start off. I'm going to actually share my screen now. So thank you, Jose. Give me 1 second. Can you guys all see my screen and hear me okay?
Yes, I can.
Perfect.
Hear you while it's shared.
Perfect. Well, thank you guys so much for inviting Brian and I to be part of this conversation today. We really appreciate, the Columbia Economics Department, CFM, for having us. Brian and I are from Inventor Data Solutions, which is one of the leading consumer identity management companies in the US. So we're an original source data compiler, meaning we go directly to the source to collect our data and have over 97 million updates to our identity graph. Some of the sources that we collect our data from are directly from the county assessor's offices. So we go to every county in the US. We have direct partnerships with all the major telco providers. We go and collect Social Security information. We get public and voter registration records and thousands of other data sources to build out a robust online and offline identity graph that covers nearly every adult, individual, and property in the US. We partner with companies, you can see some of them up here on the screen, like Equifax, Crate & Barrel, Loan Depot, Bissell, to leverage Inventor's deterministic data to verify, enhance, complete consumer records. We also have powerful segmentation and analytics services to support our partners' modeling capabilities. We also partner with 12 of the leading universities, such as Stanford. I got to give a shout out to Franklin. Thank you for including us in that study. And thank you for speaking so highly of our data. It was really, really interesting to see all of the great work that you were able to do with this data on rent control in San Francisco. We also work with partners such as Notre Dame, University of Chicago, Penn State to support their economic and social policy research. Inventor's total consumer history data set has really been revolutionary for our research partners in the space. And we've found that it's unlike any other data set in the market. It tracks up to 30 years of address and alias history and is what the main data set that Franklin and Stanford used for their research study. And so it's able to show 30 years of address history across and show consumer movement across geographies and social classes. So to supplement this data set, what we've done is we've created historical snapshots of our historical demographic file, our automotive file, and our property file. This enables our research partners to understand truly a 360-degree view of the individuals in the US and track how they've changed over time. These data sets include information such as age, gender, wealth information, marital status, do they own versus rent, do they have children, is the individual alive versus deceased, what type of home do they have, how many bedrooms, how many square footage, the type of cars they drive and they've driven in the past. And these data sets have really enabled our research partners to study the effects of rent control, immigration laws, incarceration, the effects of natural disasters, the effects of innovation and how it changes the economy around it, and changes in zoning policy as well. What we've seen is since COVID, we've seen a huge increase in our research partners looking to study the ongoing effects of COVID and how that's changing individuals and our economy. And are individuals moving? Are they moving out of densely populated areas? How is their lifestyle and wealth changing? Have individuals passed away? And I'll let Brian dive a little bit deeper in some of these data sets, including some of the digital data sets that our partners are leveraging to be able to have the most relevant and complete research.
Thanks, Grace. Yeah, Inventor's strength is really focused around identity. And so we take a deterministic view of the consumer and their identity information. The telephone data, as Grace mentioned, we source directly from telephone companies where available. The digital information we're collecting from online publisher partners and SDK vendors, and tying that back to the offline identity graph. So we have a strong view of the digital identity. It's not an inferred relationship as we link that to the graph.
Perfect. Thank you, Brian. I'll give you back the control, Jose.
Thank you very much, Grace and Brian. And our next speaker is Sylvain Champenois, who of course is from CFM, previously our student at Princeton. And CFM, of course, this is the CFM-PER initiative. So they are partners on all the programs that we're building around data, around big data. So, Sylvain.
Yeah, so yeah, thanks very much for the invitation. So CFM is a quantitative asset manager. So we consume a lot of data, a lot of alternative data, and within that, some geolocalization data. So just to rebound on the presentation, so I'll make a few points. So the first one is when you look at all the presentations, you'll see that like the speakers combine several data sets, right? Whether it's like some census data with like restaurant data, or whether it's like transportation data or geolocalization data. And the lesson, it's also what we do, right? When we consume data, we need to merge a lot of data. And that's really a crucial point of what we do, right? So it's big data is very often not like very large data set, is a combination of a lot of small data sets, and that's how you make it work systematically. The second point I'd like to make is that like, so we care a lot about predicting stock prices, right? So we're a hedge fund essentially. So so for instance, like a high signal to noise ratio is like, is it possible to know the sales growth number of the firm that's going to report in 2 days? Well, it's illegal to know that number in advance, right? So what you need to do is find proxies to, try to have an estimate for the say the sales growth number, and we will use a lot of geolocalization data to do that, because if you can track the number of people that go through a store, it tells you, it gives you an insight about, whether sales are going up or down, and that's good. But what you want to be aware is that this is a noisy proxy. You're making assumptions when you do that about, say, the propensity of each of those clients that walked into a store to actually buy something. And if, that propensity varies over time, your proxy will be very noisy. And then the third point is, so we really hunt new data sets, right? So we really try to talk to firms who've never talked to other hedge funds before. And, those companies, their main business is not to provide data to hedge funds, it's something else, right? And so very often the data that we get is quite dirty. So it's it have bugs, it have outliers, and you need to live with that. So, if the data is really clean, it means it has no value, right? It has Bloomberg IDs and dates, and it's easy to find. It probably has no value. So a lot of what we do, when you think about, when I did my PhD, indeed 15 years ago with Jose and Harrison, is like, in finance, you might have a lot of economic questions, but really there were only 3 or 4 data sets that you could use that were used in finance. And today it's the reverse. You have a lot of data sets, and you need to think about really what are the economic questions that you want to ask with all these data sets that are available. And geolocalization is really special because it provides a lot of information about how firms operate, how they interact with consumers, with suppliers, how they react to shocks, whether it's shocks like COVID or weather and so on. And for us, it's a big source of alpha, of new alpha that we are harvesting with that. And I'll stop here.
Thank you, Sylvain. Thank you for joining us. Our next speaker is Michael Reche from Neuberg Berman. He's the leader of their data science team.
Hi, thanks for having me on the panel. Yeah, so what my team does is we also use a large data sets and multiple data sets, and geolocation certainly one of them. And slightly different from Sylvain's case, we're not so much looking at predicting stock price as we are in understanding intrinsic value of businesses. And so essentially what I mean by that is if you analyze in detail a business, let's say a company grows by 10%. The question is, did it get 10% more customers? Did it get 10% more loyalty spent from the same customers? Did it raise its price by 20% and lose some of its customers? And all of those three scenarios lead to completely different outcomes in terms of the long-term future value of the business. And so we're looking at data sets to evaluate cohorts of customers and looking at the choices they're making. And a lot of this also ties back to some of the prior talks in terms of looking at the nature of the demographics. Now, unlike the first speaker on the panel, we don't want to know about identity. What we want to know about is sort of the nature of demographic groups. So for example, if we look at credit card transactions, we infer who's a renter and who's a buyer, because we see bank account transactions as well as every row by row credit card transactions anonymized, about 10% of the US population, for example. But if your largest payment in a month is probably your rent or your mortgage, if there's pennies involved, it's a mortgage. If it's round dollars, it's rent. We break them into demographic groups so we can look at the nature of the income, the geolocation of the household, the fraction of income that's being spent, whether it's a steady income, the mix of the way that spending is occurring. Of course, these data sets don't go for whole economic cycles, but you can look at small sort of economic fluctuations, like for example, in 1516 in Texas and Oklahoma, there was sort of a mini recession in the last fracking bust. And so you can look at what pressure occurred on households there in order to understand the nature of, to build sort of a macro early indicator type process to look at what's happening. Now, under COVID, I mean, obviously, this is a time when geolocation is really finding its fore because people are changing their behavior in very dramatic ways. And you want to look at how individual demographic groups within the population change their behavior. And in particular, there are going to be a set of businesses which are going to become winners in this process. And there's a bunch of businesses that are going to become losers in this process. And part of what asset management is trying to do is pick the winners early. And I'll pass them. Thanks.
Thank you, Michael. Our last speaker is Yanis Tsiounis from Advanced Research Corporation. And they basically produce data for finance. Yanis?
Hi, everyone. Hi, everyone. Can you see my screen? Can you see the slides? From Iris. There we go. Hi, everyone. So this is Yanis. What Advan does is we share cell phone, we compute cell phone location data. Sorry about the technical problems here. We compute cell phone location data in bulk. We are essentially an aggregator of aggregators when it comes to location data. We purchase it from about 1,000+ applications. It's all accurate data. It's all explicitly obtained from the end user. If we can go to the next slide, please. Just to give you a sense of size, we get data from 100+ million users. What is more important is not just the number of users, but how frequently you see them. So we see them at least 100 times a day, which means we can do a lot of analytics on the users. In the US, we see 1 out of 4 smartphones on a daily basis. This is the most data that can be purchased. On top of that, we add data curation. So if you click enter, you'll see the maps that we generate. So for every location that we cover, we manually draw the perimeter of a location and the parking lot. We are the only ones that have done this in bulk, almost a couple million locations. And in addition to that, we have another 140+ million points of interest for a total of 150 million. And yeah, you can change slide. And what it means is that when you're measuring traffic and you're correlating to transactions to actual revenue of companies, you get a very high correlation of the two. We focus, most of our customers are hedge funds. This is our bread and butter where we sell to. No, please stay in the previous slide. And what we generate is foot traffic for more than 2,000 companies. We measure both the consumption side, where the retail consumer goes, as well as the supply side, traffic in factories, number of employees, truck traffic going in and out of factories, and we go to all the level of detail that is required for finance, point-in-time store openings and closings, M&A transactions, measuring dwell times, measuring parking lot traffic, measuring cross traffic, etc. If you go to the next slide, we'll show a supply example. So this is an example of measuring the traffic in Tesla factory, not just the whole Tesla factory, but the portion of the factory where they park the new cars, and lo and behold, correlation to the actual car production is 0.98. If you can go to the next slide. We've verified our estimates with actual foot traffic counters, people counters, cameras that monitor people going in and out, and we are within 1% of the actual ground truth. Next slide, please. This is an example of capabilities to do free-form queries, so we can geofence any area on the fly and measure the traffic. This is an example on the Las Vegas Strip. You can see what happened after the terrorist attacks in 2017, pretty much nothing. And you can see what's happening now with COVID, which is a lot. So hopefully this is temporary. So that's the idea of what Advan does. We also, I think it's important to mention, just released the tool for free consumption. It's on our website, advan.us, under hotspots, where we measure the true congregation of people. For every city block around the world, we measure how many cell phones have been in the same city block at the same time, excluding drive-bys and excluding people who live there. So you can see how many people congregate. And we show a map, an interactive map of the whole world that shows when more than 50 people have been at the same place at the same time and how that changes over time. So it's very interesting to see New York City having the most traffic in hospitals these days, as opposed to Times Square than it used to. Thanks.
Thank you, Yanis. So I think we finished with our initial presentations. I think we're going to proceed by having questions and Q&A. There are some Q&A, but I would start by using my privilege to ask a question myself, and that's mostly towards Michael and Sylvain. So we're getting this enormous amount of data coming, being available. How do you take care of the possibility of overfitting? Because in general, in economics, you find a lot of relationships that, and especially that hold for the data set, for the amount of data that you have, but they don't have any relationship with the true data. So if you get new data, they won't hold. So how do you think about that with these data which are very, very large?
Okay, so maybe I'll go first. I mean, this is obviously a challenge, right? So with these data sets, very often you get a short sample, right? Because they haven't been available for very long. So if you want to identify slow-moving trends in a very small data set, you won't have a lot of statistical power. It's going to be very hard to identify whether indeed your data is predictive of anything. So very often these new data sets have been used to predict really fast short-term movements of the stock price. So and because you're sampling the data more frequently, then you run a back test. You hope that all your points in your sample are point in time. There's no forward-looking bias, and then if you have enough of those returns that you predict at a high frequency, then you're be able to check whether your insight is predictive of returns. So that's sort of the statistical way of testing things. And then what's also very important is to have some, economic theory or some insight or some sensibility that you can test, because at the end, the best regularizer is theory, is like a theory of what's happening. So I guess that would be the second one. And then a third point to say is that very often what we try to do is to have ancillary tests. So obviously, what matters for us is to predict stock returns. But very often we want to have some sort of other variable that we try to predict, right? So with the example of like foot traffic, right? So really the theory of why foot traffic is important for stock returns is that it affects fundamentals. And so we'll have a lot of ancillary tests, right? Is my foot traffic still predicting sales growth or something like that? One point I'd like to make also is, there's some environments, some markets that are really data rich. So in the US, we have a lot of information about firms, right? And so very often when we look for new source of data, we look for markets where you don't have a lot of data. So emerging market would be a place where actually there's so little data that if you can find some data set that's reliable, some satellite data set or something like that, it's going to be really, really useful. The value of that data set will be marginally much higher than like if you find something, in the US. So we'll look for those data sets that are also very different and that can tell us something that we don't know already.
Thank you, Sylvain. Michael?
Yeah, so we're one of the things. So we have very large data sets, but one of the things we don't do is take and look for arbitrary correlations with data or data mining. So what we do are fundamentally driven. So for example, let me give you just a concrete example. Let's say the CEO of McDonald's hasn't told you how they're remodeling all the McDonald's experience of the future, order with iPads. They're not telling you how it's going because they're not very far through. But I can take the very frequent visitors to McDonald's and create a sub cohort of those frequent visitors. If they all stop going to a particular McDonald's, they haven't all changed their habit, it's closed. And if they close for a month and then reopen, then basically it's unmodernized. So then I can take hundreds of McDonald's that have been modernized and look at the engagement of customers before and after and answer the specific question, and I answer it statistically. So the other thing I would say is that removing bias is great, but detecting bias is equally important. And so what we do is we find ways of actually looking across data to actually detect bias. And I'll tell you a very quick example of that. And I'm glad that Yannis talked about mapping the building. So this is an example he's heard before. But let's say I look at McDonald's, I can look at the cell phone location data and say, what time of day are people visiting the McDonald's? Now, if the profile of numbers by time of day is the same for every McDonald's, that's great. If one looks very different from the others, then either you've oversampled it or you have an error. And so, for example, when I look at cell phone location data, I found a Costco on the peninsula in California where the peak visitors was at 8 a.m. Well, you look at on the Google Maps and you see that the loading dock backs upon the 101 freeway. So I call them up and say, look, you're getting the freeway traffic. They say, no, we have a filter on velocity. I said, no, I've been in that traffic, you could walk faster. And so the point is that since they map the entire building, the loading dock of the building is almost sitting under the freeway. And so the thing is that you have to find questions that you're going to ask across that are perpendicular to what they've done in order to try to detect and remove any sort of problematic data. Sorry for the long answer.
No, this was very good because we could continue and then we'll go to the question. We could continue by asking the other panelists exactly the questions that both Sylvain, what you and Sylvain raised. So Sylvain raised the question, how global collection you make, how important, because he thinks that for markets, for using in the markets, you need things which you can exploit that, in places that we don't have a lot of data already. And for you some of this work should be done by the data collector, right? I mean, you raise points that sometimes the data tells you things which are not right. So maybe Grace and Burke and Yannis will take a crack at some of that. Let's start with you, Grace.
Can you guys hear me okay?
Yes, now I can.
Okay, perfect. Yeah, I was actually going to hand that one over to Brian. He'll be able to dive a little bit deeper into how our data can be used considering its rich history.
Yeah, and so the way, Infutor sources our data from deterministic sources, by and large from public record sources as it pertains to the property data. And so, we've got permissible use as the way that data is collected. I don't know if that answers the question.
And do you do any work outside the United States? Do you do anything? Do you have any global coverage?
We're by and large, we're focused within the U.S. We do have some Canadian data as well, but we've really chosen to focus primarily on the U.S. And even in the U.S., and particularly as you look internationally, as it pertains to consumer data, there's an ever increasing focus around consumer data privacy. And in Europe, there's the GDPR, and in the U.S., there's the CCPA with the California Consumer Protection Act, and there's an increasing awareness that consumers have a right to privacy and have a right to the way that their data is collected. And so we try to be at the forefront of that, and we assume, even though we're primarily focused in the US, that eventually we think that most municipalities, most states, hopefully the federal government at some point, adopt a GDPR type view of data governance, where consumers have a right to see what data is being collected on them, and then also a right to opt out of that information. And so we collect our data only in cases where the consumer can provide consent and allow that information to pass. And we've also rolled out last year in response to CCPA, but we've taken the tack that we think it's going to eventually become national, a program to allow consumers to look at what data is collected on themselves and opt out if that's their choice.
Thank you. Thank you very much.
Yeah, let me answer that question as it pertains to actual investment professionals, which is very different than the rest of the marketplace, because investment professionals don't care what you and I do. They don't look at individual device data. They don't look at where a device has gone, which is what marketers and advertisers do. They care about actual traffic. So what we found out from the provider's perspective is that because we've been doing this for 5 years and that's all we've been doing, we know more about the data than every one of our customers. And also a misperception in the marketplace is that, well, the hedge funds, they have all this money, they can do everything. The reality is they have very little support for every single action that they have to make. So they're even the ones that have data science teams, those teams are 10, 15 people, and they have to analyze 5, 10 different data sets. Well, guess what? We are more people and we analyze only one data set, and we've done only this and nothing else for the last 5 years. And we're building it, so we understand it more. So we provide a lot of support. We do a lot of that groundwork, which is find all the locations of all the companies. If a location closes and if a location opens, we mark it. We do year-over-year comparisons of same-store sales, of comparable traffick, which is what the fundamental analysts need to do. We tie everything to a ticker. We tie everything to a persistent identifier so that the quantitative funds can use our data without having to change their own processes. They can embed it into their systems, and so on and so forth. And we do all of that internationally. We have international data. Now, you have to think of the perspective here, what it means to have international data. The US, whether we like it or not, moves the world. It moves the markets. It's a very heavy consumer economy. 70+% of the GDP is consumer spending in the US. You look at the traffic in malls in the US, it spikes over the weekends. In Germany, they're closed on Sunday. Right, and it's completely different than the rest of the world. So when we measure geolocation traffic by country, we keep it separate by country. So here's the US traffic, here's the Canada traffic, here's the UK traffic, here's the German traffic, here's Italian, Japan, Australia, whatever. And we do some analysis on top of that where we combine them. But really, it's up to the investor to figure out, okay, I want to place more weight in this country for this company. Obviously, if you're looking at Sainsbury's, which is only in the UK, you're going to look at the UK data. But for international companies like Walmart, does it matter that
your coverage is pretty wide? You just for the customers to decide which portions they want.
Yeah, I mean, you're looking at Walmart. Do you really care about all the 50, 100 companies that have locations, or do you think the US is going to really move the market? And the reality is the US is really going to move the market, and the rest is a little bit ancillary. So we tie it up. But there are cases where international data will be important for specific companies or even specific locations. And that's why we've taken great pains to have global data.
All right, we have some questions now. I'm going to start from a question from a Yanis to a Yanis. Just by coincidence.
It's a pretty common name.
Yeah. Do you foresee after COVID to have a move from foot traffic to browsing traffic? How do you get the data?
You know, I don't think people are going to not go out of their homes forever. We'll see this environment. This is just a gut feeling. I have no scientific data. Nobody, I think, has any scientific data, but it looks like the environment we're in is going to persist for a few months, maybe a year, maybe two. But it doesn't mean that people are not going to go out, or they're not going to go out in increasing frequency or different frequency at different places. There will always be need for measurement of movement of population. And even though the movement has decreased materially, it hasn't decreased to zero for everything or universally across the board. So that's really what we're measuring. In fact, if anything, we have seen a huge surge in demand for geolocation data in the last couple of months, because that's where now there's differentiation, as Michael said earlier. Now the geolocation data becomes very important. It's true differentiator of what's happening, and you can see the recovery. In terms of browsing data, it's not something we've done. I don't think it's something we will do. I don't know if it's very important. I think the measuring actual credit card transactions for internet purchases is more important than measuring the browsing, because you're measuring actual when people actually spend as opposed to just browsing around. And that data is already covered. We've partnered with Consumer Edge, which has very good transaction, the best transaction data. So we don't really see a need or a big gap on just browsing data, frankly.
Thank you, Yanis. There's a question here for Michael. Can you account for cultural background differences in otherwise similar demographic groups? So I suspect you're looking at whites, whether you're looking at people who come from Central Europe or from Mediterranean origin, etc.
Sorry, I didn't completely understand the question, but let me maybe.
Yeah.
So I want to touch briefly on this whether behavior is going to change in ways that that don't go back to that are a new normal. And I think I would just give and I think that partnering with a credit card transaction source, I agree, as Yanis says, helps to fill the gap, and you don't necessarily need browsing activity. But for example, insurers are now paying for telemedicine, remote consultations with doctors, and they weren't until a month ago. That never goes back. Many firms who had not tried remote working now have their entire company remote working, and it's in many cases it's working very successfully. You don't go back to not having remote working. So I think that the amount of travel, and also as long as there's a risk, obviously if you quarantine the entire country like China has, then people might go back to restaurants. But if you haven't quarantined the whole country, then people they're going to change their behavior with respect to public transportation and restaurants and ride sharing. It was amazing that the number of bookings for Uber Eats was higher than the booking for Uber. And so, so these patterns won't go back. But yeah, so we are certainly looking from lots of different data sets at the behavior across different geographies. And we're very interested in this large-scale science experiment which is going on, which is everything being tried differently by every jurisdiction, whether that's a country or a state, or and we think that that's going to lead to a diversity of different types of behavior, and we also think that some will actually control the situation better and others will control it worse, and there will be economic impact. And just to say one other quick thing about that is it's very interesting that generally from an economic point of view, in growth periods, companies increase their inventory, and in recessions, they decrease their inventory. We're now seeing a recession where people are increasing their inventory. And part of that is because they have supply chains, and they don't know what kind of transportation issues or delivery issues are going to occur in their supply chains. So they're being forced in a period of recession period to actually increase their inventory. So that's going to disadvantage companies that have long, elaborate supply chains, and advantage companies that actually have more control of their means of manufacturing and of their access to their customer base.
So what Michael said is very important, because I think you're talking about this. That's going to affect globalization in a sense, because the globalization typically depends on very long supply chains, and we're going to have companies are going to react, I guess, depending on companies which are very far away. What Michael did was very good, because he got the dialogue going, reacting to Yanni's answer and so on. So I'd like to ask both Grace and Brian if they have any reaction to these statements, both by Yannis and by Michael. And of course, Sylvain.
Yeah, I think as it pertains to the browser behavior, whether behaviors have changed as a result of COVID, I mean, I'm certain that may be the case. Where our focus primarily is on the linkage of offline and online data. And so if we look over a longer period of time, we might be able to help show trends that would show, for example, migration patterns or things of that nature. But it's not really our area of focus in terms of behavioral point of interest data.
Sylvain?
Yeah, so I think for us, the key sort of economic question is to understand how firms operate again. And so when you think about this, so, on this brick and mortar versus online presence, you want to track both, right? You want to have some understanding of like, what is the physical presence? And then you have an understanding of like, what is how much traffic is happening online and how much sales are happening online and so on. So you want to have both, and then you want to also see the supply chain, the relationship with like, the workers, the analysts, the suppliers, and so on. So you want to build that kind of like a knowledge graph of the firms that will help you understand how shocks get propagated, who are the winners, who are the losers, and so on. So I think, to me, it's not like a either or. You need to, have some, proxies for what's happening everywhere. And indeed, if like we move from a world where like there's more social distance and a lot of it is happening online, you don't want this to be a hole in your tennis racket, right? You want to have a way of like capturing what's happening there. Similarly with like supply chains, right? If suddenly like having a shorter supply chain is a competitive advantage, can we identify the firms that are going to be well placed for that? And there's some data that will give you some answer with some noise, with some assumptions, but that's the way you can make wise, informed decisions in a portfolio, for instance.
Thank you, Sylvain.
Yeah, and actually just to add to that, we're seeing a lot of that today, and where we're helping to bridge the gap with businesses are with businesses that primarily relied on offline data, as Brian mentioned. We're working with our clients to bridge that gap to that migration from offline to online, and since that digital traffic is way up. So we're helping our businesses that we partner with understand the impact on their own customer movement as they work to be able to create a digital strategy.
Yes. So for instance, if you're looking even at, restaurant chains, for instance, the ones that had a much better system of delivery, something like Domino's, has done much better than another, like McDonald's, which depends more on foot traffic and so on. So, I mean, this gets to what Sylvain was talking about. We have to understand how this changes. If this, first of all, if this is a permanent change, or if this is just a temporary change for that's going to go away and people are going to start walking to McDonald's again, or if they're going to depend more and more on having delivery and so on. So I have an organizational question. It's not for any of you, but is it possible, one of our listeners is asking, viewers is asking, Is it possible to post on the chat the contact of presenters and panelists? Is there a way we could make that available? I don't know if the panelists themselves agree to that, or presenters. So if you want to be posted, maybe you can communicate to the organizers, and the organizer will try to put it somewhere where we can talk about. I have one more question for Advan. So when you're producing, as opposed to when you're producing summaries of individual behavior, so people could kind of follow it in some sense, is it possible to anonymize it enough so that people, that the concerns that people have, privacy concerns, are ameliorated, but still people have access to large data sets where you can follow individuals?
Yeah, so what Advan mostly does is aggregated counts of some sort. I don't know if I mentioned that we have the hotspots in our website. That's actually one of the most detailed measures that goes down to the city block. But even there, we don't tell you there was device 1, 2, 3, 4, 5, an anonymized device number. We just tell you there were 50 people there, or there were 100 people there. So you can zoom in and see, okay, this is actually a Walmart. People are shopping. This is a hospital. This is Times Square. This reflects also what we do for our customers. Again, the vast majority of our customers are hedge funds. They don't care and they don't want to know any private information. It's all risk for them with no reward. So what we provide is traffic measures. We'll tell you that there are 1,000 people that went to this Shake Shack today, and they stayed that long, and that was 2 months ago, and now this particular Shake Shack is closed because there's nobody there, or it's open and you only see delivery people coming in and out, the same devices over and over. We'll tell you these kinds of metrics, which can be customized by company, but they're not even, first of all, everything we receive is anonymized, but we don't even provide anonymized data. We only provide aggregated data. So it's impossible to revert back to the actual person. I think that's more of a concern when you start building, when you start working on device level information, which is what companies use for advertising, for marketing, for identity management. So this is more of a question for Infutor, actually, which is their business.
Infutor, but let me tell you, I live close to the original Shake Shack, which is Madison Park, and they're open. You can't consume there, but they sell you stuff.
Yeah, they'll sell you stuff, yeah.
This is Brian.
Right. So, Brian.
Yeah, to speak to Yannis's point, as it pertains to identity and consumer privacy, one of the ways that we deal with that, and by and large, the data industry will often deal with it, is we use what we refer to as synthetic keys or a personal ID number. So essentially removing the personal contact information and replacing it with an anonymous digital identifier that can be used for tracking across data sets, but purely for the point of tracking a household or an individual, but there's no way to unmask or decrypt that back to the root identity. And so it's useful, particularly if you're looking at migration patterns over years, or you're linking amongst demographic data sets and location data or digital data. It's useful to have those keys for linkage purposes, but not from an identification standpoint.
Thank you, Brian. So the kind of research that you saw here in the first paper by Don Davis, where he linked, from public data, of course. In principle, you could do that kind of research with data which is not, self-reported like Yelp is.
Right.
So he was interested in knowing where do those people live, where do those people probably work, and where do they consume. And but you could do that. Listen, we are, our time is all. Harrison, do you like to take some more questions? I don't have any questions for the speakers, for the original speakers. Would you like to take some?
Yeah, sure. So
all my questions are for the panel, the ones that came here.
So are there any other questions for the speakers that anybody would like to ask? Otherwise, I think I'll just close by we can kind of close since we're running against the 1 p.m. deadline. Any other questions?
I wonder if I could ask a question. There was something that Michael said, which of course is entirely right, which is we're engaged in this grand experiment where we're trying to figure out who can actually work from home. Can you monitor? We're much better at measuring inputs than we are outputs. Are we doing well enough in terms of measuring outputs to know which jobs can actually be shifted to home? To a certain extent, office space and retail space is supplied inelastically. So I think that something will come back in those spaces at some horizon. And I'm just wondering whether you have insights about paths into understanding how retail within cities, it's in person, how the use of office space that matters both for obviously real estate industry, but ultimately also for construction. I'm just wondering how you're thinking about using the kinds of data sets that you have access to think about those economic impacts.
I'm happy to start. I mean, I think that retail and commercial real estate is going to be long-term impacted. I have to believe that. I mean, the whole calculation of, I'm willing to pay higher dollars per square foot in order to be in the density of foot traffic. It looks a little bit different from in post-hoc. Again, you could say, well, maybe in 2 years we have a vaccine and we're all immune to that. But then I think the awareness of possible future similar type of events, I think there are lots of trends in behavior that were already occurring, and I think that this accelerates a lot of those trends. But yeah, I think that it's going to be a completely different mix. And the other thing is, I think that some of the ways we think about public transportation and restaurants. I mean, look at restaurants in New York, for example. A lot of them only are viable at 75 to 80% occupancy rates or higher. So there's a lot of change that's going to occur as a result of this.
What about universities, Michael?
Well, I've been telling people that there was actually an article in the Wall Street Journal, but I was telling people before that you look at K-12 and the governor can say K-12 starts again, but having been a university professor for 25 years, university professors are relatively powerful compared to K-12 teachers, and I think a lot of them just don't want to go back to classroom education. There was a trend towards online education, but we only had University of Phoenix as an example, and people weren't respecting sort of online education, which they should be. And I think that this is going to accelerate that trend too, to remote learning and online education. That's another trend that's just it's just going to persist. And large classrooms full of 300 people. I mean, professors they want to go do their research in their lab, but I don't necessarily think they're going to want to have that environment again.
Okay, Harrison, I think we passed the time we're allotted, but I hand it over to you and thank all the panelists. This was a very good panel. I learned a lot. And the speakers too. I learned a lot from the speakers.
Great. Thanks a lot, Jose. It was great. Thanks for all the panelists. Thanks for all the speakers. So I think we'll end it here. This was really great 2 hours and we pulled it off very, very last minute. So thanks a lot for that. Charles-Albert, do you want to say any last words for CFM?
Nothing more than you said. I think it was very, very interesting. And as Silva underlined, I mean, now we are in a situation where we've got too many data sets. So we need to be inspired by economic insights. And this kind of workshop is exactly what we expect, to have new ideas about how to use all these new data sets to have some insight about the reality of the state of the economy.
Great. All right. Thanks a lot. So I guess we'll sign off.